something wrong. I'm going to allow to speak to him. Uh, yes, tell me.
Sir, I had sent you mail yesterday, sir. Please check
Yes,
it.
yes, yes, yes. I received it. I think total there are 20 students are admitted. So I'm waiting some of us. I think you are not sending all the email IDs. So I'm waiting some few of your students. But I'll wait by today afternoon. Then after today evening, I'm going to 8 in our MS team. Okay.
Okay, sir.
So now come up here. Why I am taking a repetition number of cases is that my target is that you can understand very basic fundamentals, including the even odd functions, operating properties, because in the GATE examination they're asking these type of questions. Then what are the assumptions of the Fourier series? What will be happen if it is odd and even function? They're not asking to solve this very big differential equation. They're asking small questions, which is conceptual questions. They're trying to find out that the candidate has capacity to understand the fundamental or not. Because in engineering mathematics, you can solve the problem, but you are not able to understand some basic cases. For example, in the case of this Fourier transform, we are talking about a symmetry of the transformations. So they may ask the questions that in the case of Fourier transform, to maintain the symmetricity of the transform, right? What is the situation? So here it is going to be multiply 1 by square root of twice 5, both in capital Fs and small fx. So these type of basic, very basic fundamental questions are going to be asked in the GATE examinations, and some of the questions may be solved to means little bit difficult type of questions, but too much not difficult. So these topics, properties, you have to note down that it can be useful in the GATE examinations. Okay, now again, come up in the case of our I am preparing some number of solve questions of this Fourier transform along with some tutorial sheet. You can get answer of a tutorial sheet. Then you can practice it and you can get very confidence after solving number of problems. Now, thing is that don't try to copy paste whatever I have provided solve problem or whatever the solve problem in the book. Try to solve the solve problem first, then try to understand step by step what books are trying to solve. Try to understand step by step whatever I'm going to provide as solve problems. After solving 20-25 solve problem, you can go for unsolved problem. Now you try to first compare that out of suppose 15 unsolved questions, how many are similar I have already solved in a solved problem. Similar means the types are similar, the ranges are similar. They may ask the sine transform, cos transform, or general transform. I'm talking like this. So try to sort out a similar type of unsolved problem with a solved problem. Then try to solve the similar type of unsolved problem. Then once you become, I am now confident, try to solve the problem which is not exactly similar with the solved problems. So this is the basic idea at the beginning level, how we can go the means confidence building to the problem solving. Sometimes the answer given in the book may be in different form. So you must have confidence that yes, mine is correct. Because if they are not asking proof that and so that, then the answer may be different. Because I may solve in one of the methods, you may solve another method, but the final may be in different form. But if I put the value of x, I can get the unique solutions. But it may be some maybe in terms of sine form, some may be in cosine form, because sine and cosine are linked to each other. So don't confuse that मेरा solution यही है, but book में means answer जो अलग दिया हुआ है. Try to understand that your answer also correct, but you have got the answer in different form. Okay, because they're asking only just transform. They're not asking to prove it. So in that case, don't confuse that मेरा तो answer अलग है, book में अलग दिया हुआ है. Don't confuse that. Your methods may be correct if you are not doing any mistake in the calculations. And what is the backbone of the Fourier series and Fourier transform? The backbone is that you should understand the integrations. If I don't know integrations, then I cannot solve the Fourier series and Fourier transform. Second thing is that if I know the integrations formulas, I should know the properties also. Even function का property क्या है, odd function का property क्या है, what are the properties of a definite integrations, if it is even function, if it is odd function, if it is sine function, if it is cosine function. All these things, integrations, we need to understand, then only I can do the Fourier series and Fourier transform. Otherwise, I cannot do that. Okay. Now, one of the main applications is that we can solve the partial differential equation also with the help of the Fourier series. One of the applications. There are more applications, signal processing to detect the number of formation in the subsurface. There are a number of applications. In the foundation level, we should understand all these things. Okay. Now, sine Fourier transform, cosine Fourier transform, and Fourier transform. All three things are only in Fourier transform. Okay. But we have specific written in the form of sine in separate form, in the form of cosine in the separate form. In this, two are coming from the sine Fourier series and cosine Fourier series. See, in the case of Fourier series also, we have classified three cases. First case was that it is in general Fourier series, means it is the combination of sine and cosine. Second part was that it was sine Fourier series. Third part was that cosine Fourier series. The Fourier transform is coming. First Fourier transform is coming from the general Fourier series. Second, this is sine Fourier transform is coming from sine Fourier series. And this third cosine transform will come from the cosine Fourier series. These are coming from the derivation, and we are maintaining all of case as a symmetric cases in the both cases. So some of the book you may get in different format, but you can get the answer will be exactly same. But if somebody asking that is the same answer we cannot get exactly same answer if we don't consider the symmetricity. If we only consider the magnitude, then we can get the same answer. But if we require for the symmetric of the solutions, then we can get different answer, means different point of view in the significance of the symmetricity. This will come once we draw the graph only. We can get symmetric or non-symmetric. But in number of books, they're not talking about asymmetry. These books I have taken because this book is discussing very basic and fundamental things which needs to be understood to sit in the GATE examinations, to apply in the petroleum technology. Because this book is considered as a textbook, and you can get number of BS level books. There are a number of engineering books are here, but this book has to be considered as a textbook because they speak about a systematic everything basically. Now come up here. We are not going to how it is coming. We are going to concentrate as a petroleum engineer because most of cases we are trying to apply the formula. We are trying to apply the property. We are trying to apply the algorithms as a petroleum engineer. Because we are not going to take the degree in the mathematics, we are going to take the degree, we are going to apply the mathematics in our core branch. Our main target is to be in petroleum engineering. So in that case, we are not too much interested how they have derived. We are very much eager to understand what is the property. Why it is required the property? Because according to the property, we have to apply in the petroleum science. What are the theorems? Why it is required? Which theorem is suitable for our petroleum science? And third is the formula. What type of formula and how the property is going to be applied? Means what are the conditions in that particular formula? Because this condition has to be satisfied with our conditions. Then only we can get. We don't want to solve all the long derivations. We want to try understand the formula, conditions, properties, and theorem, because properties has to be satisfied, condition has to be satisfied, and formula condition has to be satisfied, and only we can apply it. So this is our main aim as a petroleum engineering, to learn the engineering mathematics. So we have to remember the three types of Fourier transform. One is in general Fourier transform. Second is talking about the sine Fourier transform. third is talking about the cosine Fourier transform. Now, if somebody asking that Fourier transform means I have to apply in general Fourier transform. Now, if somebody asking sine Fourier transform, then I have to do only sine Fourier transform. If somebody asking cosine Fourier transform, then I have to do only cosine Fourier transform. This is the classroom and textbook example, whatever I am talking. Now, as a petroleum engineer, if I take a real life problem, suppose I want to solve some partial differential equations, which is in fluid flow in porous media for the reservoir. No one is going to tell you that which method you have to apply. I have to decide myself that what type of methods I have to apply to get the solution. Because it is talking about the accuracy level. What type of Fourier transform is going to be applied? यहाँ पर साइन फूरियर ट्रांसफॉर्म अप्लाई होगा या कॉस फूरियर ट्रांसफॉर्म अप्लाई होगा या जनरल फूरियर ट्रांसफॉर्म, कौन सा टाइप का फूरियर ट्रांसफॉर्म अप्लाई होने वाला है? But in a textbook in the classroom, it is written that find out the Fourier transform, find out the sine Fourier transform, find out the cosine Fourier transform. You can get 10 out of 10. But as a professional, as an engineer, as a petroleum engineer, if I have to solve the hydrocarbon transportation from one location to other location due to the migrations. Migration कैसे होगा? Due to the different type of activity. For example, pressure difference, right? For example, geological structures. These are the reasons: porosity, relative permeability, capillary pressure. These are the property that it can migrate from one location to other locations. Now, how to define? We can define with the partial differential equation. हमें उसको solve करना है. How to solve it? One of the method we can apply Fourier transform. Now, there no one is there to help you because it is not classroom now. Because you are not petroleum engineer, as a reservoir engineer. How to solve it? You have to decide yourself. Should I use here normal Fourier transform? Should I use here sine Fourier transform? Should I use here cosine Fourier transform? I have to decide myself. This is the difference between classroom and as a professional engineering. Then how we can decide it? I can decide that this particular method can be applicable here. It may be sine, cosine, or normal Fourier transform. How? I should understand the properties. I should understand the assumptions adopted in that particular method. I should understand the theorems. Then only I can say, okay, in my situation, this method is becoming very suitable methods. For this particular problem, this method is very suitable. That's why we need the fundamentals things are here. Okay, so Fourier transform here, capital Fs, number of books they write small f omega, because omega is the angular frequency. Okay, some of the book write capital Fs. Some of the book capital Fs is applied in the Laplace transform. So don't confuse, just look the formula. You can understand that they're talking about the Laplace transform or the Fourier transform. Number of books they represent capital Fs as a Laplace transform. But number of books out of 10, 7 to 8 books, again they write capital F as a Fourier transform. So don't confuse in the notations. Notation can be anything. Now come up here. The formula is square root of 2 by 5, 0 to infinity ft into sine st. Okay. And if I want to find out the inverse, small fs is equal to square root of 2 by 5 integration 0 to infinity fs capital Fs sine sx into ds. Means if I want to find out the small fs, means inverse transform, then capital Fs should be given to you. Then only I can get the inverse. If I want to find out capital Fs, the ft, because see some of the book they write the ft in instead of f of x, because the Fourier series in general talking about in terms of time series. So now if it is fx, then it is become sine sx and it is become tx. Now it is given t here. Now this function has to be given, then only I can get the sine Fourier transform. This function has to be given, then only I can find out the inverse of sine transform. Now, number of books are written here differently. Instead of square root of 2 by 5, they write only 2 by 5. Again, I'm talking about a symmetric here, but they didn't mention here that all whatever methods we are going to adopt here, that we are trying to adopt in the symmetric cases. We're trying to adopt all the case in the symmetric case. See, some of the book they mentioned this only 2 by 5. They didn't classify this and this form because they are not talking about the symmetric. But we will talk about the symmetric because we're talking about the petroleum engineering. It is very helpful if we get anything in symmetric form because find out the 50% and 50% will come without calculation. That's why we believe on the symmetric. So my recommendation is that please follow this book's formula of the sine Fourier transform, cosine Fourier transform, and Fourier transform. But in the examinations, you can write any of the formulas. Okay, any of the formula. So this is our number equation one is this is called the sine Fourier transform. Number two equation this is called the inverse of sine Fourier transform. You should note down all these things in your notebook. You should have a notebook of mathematics. So in notebook you have to write everything, the formulas. Okay. Generally in the offline classes, I weekly cross-check the notebooks because in 1 week, generally I'll give 10 to 15 class works. Suppose I solve 2 or 3 problems in the classroom. Again, I have given suppose 4 class works. Next, I have given suppose I solve 3 to 4. I am giving again 2 class works. At the end of the week, in your notebook, you should have be around 10 to 15 solved problem. So every week in the offline classes, I solve individually that you are doing or not all these things. But in the offline, it is online, it is not possible. So offline, I can take care of each of you that you are doing along with me or you are not doing along with me. So I recommend you that because we may open an October as online, but this tentative very. But do one thing, you maintain one mathematics notebook where all these things, important things, the formulas, properties are written very clearly and the solved problems are written very clearly, unsolved problems are written very clearly, and you have solved the unsolved problem also. It will be helpful you. Okay. Same thing here, cosine Fourier transform. Okay. The formula is exactly same. Instead of sine, it is become cos. Instead of sine, it is become cos. Rest are same. So sine and cos में कोई फर्क नहीं है. Instead of sine, it become cos. Instead of sine, it become cos. So now, if I remember only sine, then I can write automatically sine Fourier transform. If I remember these two equations, then automatically I can write this sine Fourier transform. So it is not difficult for all of us. So now come here that this problem we have solved. Let us try to solve some example which is in the form of sine and cosine. This book is very good for the beginners and very less number of mistakes are here. So example based on Fourier sine transform. There are number of Indian author books except the B.S. Grable book. B.S. Grable book बहुत अच्छा है और in that book the typing error is minimum. Very minimum number of typing errors are there. Other than B.S. Grable, there are a number of books, for example, Jane in Iyengar. This book also good. Minimum number of errors are there. So Jane in Iyengar, B.S. Grable, S.K. Das, all these books are almost typing error free. Rest of the Indian authors' books are number of typographical mistake. Instead of Z, they are writing 2. Instead of O, they are writing 0. So you become very confusing at the beginning level. Because Z, if I write Z is 2, then how it is possible? Z is variable, 2 is the constant, so it is not possible. But in this book, whatever I have recommended, and B.S. Grable book, and S.K. Das book, Jane and Iyengar book, all these books are almost typographically error free. I mean, they are not, maybe very small number of errors are there. So find the Fourier sine transform of this. You may feel that उसका limit क्या है? It is not necessary because Fourier sine transform always from 0 to infinity. Look here in the formula. They assume that you know the limit here. If it is not given, I have to assume the general formula. Come up here. Formula, look here. 0 to infinity, 0 to infinity. In terms of cosine, 0 to infinity. If they are not mentioning the interval from which to where I have to go the interval, it means that I have to follow 0 to infinity. If it is given, then accordingly it should be in between 0 to infinity. So don't confuse here, okay? Come up here in our example now. Look here. Find the sine Fourier transform 1 by x. They didn't mention anything here. It means then 0 to infinity I have to take here. So very simple, f of x given to you. Nothing to do here, just put the formula here. Okay, if I put the formula, then I can do the integration here. If this is, and I have to do the integration here. I have all of us can do this integration. U by v formula, or you can put some integration by substitution. Okay, so left hand side is this. Okay, so Fourier transform is square root of 5 by 2. This is the Fourier transform. These integrations are standard integrations. Be careful. The value of this integration is 5 by 2. How it is coming? Integration by substitution here. Put Sx is equal to theta, so that S x dx is equal to theta. If I substitute here, I can get this one. So this is called the integration by substitution. This is called the integration by substitution, and the standard result of this integration is this. This is the standard result. The standard result is 5 by 2. In this book, it is written some useful results one on the page number this, because this book includes integration also. So if I can remember iska integration 5 by 2 have, just write down directly 5 by 2 by the standard integrations. If I don't know this one, it is very difficult to do the integrations. Okay. Now second question, find the Fourier sine transform this one. Again, the limits are not mentioned here. It means that 0 to infinity. What to do here? As per the formula, just put here. Now integration by parts. If I do the integration by parts here, I can get, this is the solutions. I'm going here firstly why? I believe that now you can do integration by parts. There is no any doubt. Agar kisi ka difficulties hai, please read the integrations. Otherwise, what happened? Unit number 2 also, unit number 3 also based on the integration, and unit number 1 is completely integrations. If I don't know integrations, then I cannot do the Fourier series, Fourier transform. If I don't know integrations, I cannot solve the partial differential equations. I cannot apply the Fourier series and the partial differential equations. That's why in the semester 3, 90% syllabus will be based on integrations. So this integration properties formula standard result, you have to remember how to find out all these things. And don't try to waste your time during the integration of the examinations, because you have to remember some standard integrations. So in this example here also, what to do? Just write down the formula and replace f of x by this. Now do the integration by parts with respect to x. अगर आपको integrations में difficulty है तो answer तो नहीं आएगा. If I know the integrations, answer will come automatically here. Look here. I can get answer here directly. I believe that you know what is the integration of this. This is the standard result. Integrations of e to the power ax sin b is equal to this one. We know this integration. Standard result we have to use. Okay. Now come up the Fourier cosine transformations. What to do? Just instead of sine, मुझे cos put करना है. Then I can get the answer. Look here. Function is this one, same function. Instead of f of x, I have put it here. Here there was sine, it is equal to cos. Now standard integration formula, look here. These are listed out. I think I had said in semester 1. सेमेस्टर 1 में जब आप लोगों को मैंने क्लास ले रहा था, आई होप आई हैव सेंड सम नंबर ऑफ स्टैंडर्ड फॉर्मूला ऑफ द इंटीग्रेशंस. I'm confused whether I had shared to you people or semester 2 in the civil branch, but I had shared one document where all the standard formula of the integrations are mentioned very clearly. So iska integration directly we know that from the standard result here. Nothing to do the integrations because आपको मालूम है ये standard result है. Now put it and put the limit, then I can get this is the Fourier sine Fourier transform. Again, this example, look here, nothing to do. Agar if I have remembered that this is the formula, if I am very confident that I can do the integrations, then all the questions of the Fourier transform, it may be sine, it may be cosine, it may be general, I assume that I know the 100% of this. Means in examinations, I can get from these topics 100%. If there is a question of 20 marks, I can solve all the questions from that particular sections. At least you can write the steps, even suppose final answer is not coming. If you know the steps, you please write the steps. The calculation may be some mistake, but you can get some marks because your steps are correct. If your answer is not coming, don't cut the answer. Keep as it is. I'll cross check the step by step. Your steps are correct or not. If your steps are correct, then according to the steps, you can get the marks. But if you cross this one, you can get a 0. So this is the very important to understand for you. Again, exponential function very simple. Instead of f of x, just put it. Here it is, put it here. Now multiply it. So I can get this 2, this and this. Now do integration this one and do integration this one. I believe that you can do the integration this one. You can believe this integration by parts. Those who are difficulty, please practice. Otherwise difficult for us. So this is the Fourier transform. Now look here. Here limits are given to you. According to limits, so look here, I have to change it. See, this function is not continuous globally, but it is continuous at 0 to 1. It is continuous at 1 to 2. It is continuous at above 2. Okay. The value of the function is x in between 0 to 1. The value of the function is 2 minus x at 1 to 2. The value of the function is 0 at more than 2. So the limit क्या है? 0 to 2. Means 0 to infinity के जगह में 0 to 2 है. Means finite number. Okay. Instead of 0 to infinity, I have 0 to 2. But inside 0 to 2, there are a number of discontinuous points. The function is continuous at 0 to 1, 1 to 2, and above 2. There is some point where function is not continuous at 1 and 2, they are not continuous. They are the point of discontinuity. Okay. Now what to do? I can here get 3 integrations. One is 0 to 1, second is 1 to 2, and third is already 0. Because third is 0, so it is not required to do the integrations. This is our formula. So f of x can take 3 values. X in 0 to 1, 2 minus x at 1 to 2, but it is 0, means 2 to infinity. So it is not required here. So now formula is like this here. 0 to 1, the function is x. 1 to 2, the function is 2 minus x. 2 to infinity, the function is 0. Means the last integration is automatically 0. Look here. ये आपको दिया हुआ है 0. And this type of step type of a function is more important in the petroleum engineering, because in the reservoir it is not possible to get out continuous things. We have to divide in terms of grid points where we can get continuous in particular grids. So that's why this is more important as a petroleum engineering. So now I hope you can do these integrations. I believe that you can do integration, and this is automatically 0. So after doing here, I can get, this is the Fourier transform. Okay, and this is very much important now here. Simple examples on Fourier sine and cosine transformation. Standard very simple here. आई हैव द फंक्शन दिस, आई हैव सबको मालूम है, जस्ट इसको रिप्लेस करना है, ओके, एंड दिस उसको रिप्लेस करना है, राइट, फॉर्मूला है. सो आई एम लुकिंग फॉर सम डिफिकल्ट टाइप ऑफ क्वेश्चंस इफ दिस देयर. ये सॉल्व है तो आप कर पाएंगे उसको. फाइंड द फूरियर ट्रांसफॉर्म, डिफिकल्ट नहीं है. Okay, look here. तो हो जाएगा, डिफिकल्ट नहीं. Just try to all these things. Okay. Some of the this example number 22, I think I need to discuss. Let me cross check all the questions. ये तो इनवर्स ट्रांसफॉर्म करना है. I'm looking some questions which will be some different type. Okay. This is important, sense of scale property. These are required because we need to solve the complex Fourier is not required. Convolution, we don't have convolution theorem. Let me check syllabus में नहीं है, डायरेक्ट हम एप्लीकेशन करना है. क्वेश्चन नहीं, it is not required. We have to go according to the syllabus. These are not required. This will be required, Fourier transform of derivative, because we have to solve the differential equations. Fourier transform of derivative, this is important. This one, solution of boundary value problem by using integral transform. They are using the Laplace, but we want to use with Fourier. This one, okay. Before that, solution of Laplace, Laplace we don't have. Laplace से भी हम solve कर सकते हैं. Solution ये तो फिर Laplace से किया है. We have to solve with the Fourier. Yes, sir, this one. Solution of partial with the help of Fourier transform. But before that, we have to find out the Fourier transform of the derivative. Okay, Fourier transform of partial derivative of function. Application of Fourier transform. Good. Okay. Our mainly two things is remaining here now. Fourier transform of the derivative, Fourier transform of partial derivative. Those is important, and one is Fourier transform of scale of the scale. Scale हम sense करके solve कर सकते हैं. Now, whatever we have learned of Fourier sine transform, cos transform, and Fourier transform and Fourier series, everything our aim was that हम heat equation कैसे solve करेंगे, how we solve the heat equation, how we can solve the wave equations. This was our main aim. Now, to find out all these things, we have to first understand what is the Fourier transform of the derivative and what is the Fourier transform of the partial derivative, and it is not difficult. We'll come up with the help of theorems, then it is not difficult. Yes. Fourier transform of derivatives. Today we don't have time. Tomorrow we'll discuss Fourier transform of derivatives. Derivatives का Fourier transform क्या होता है? this is not required. See, our only remaining is now Fourier transform of derivative and Fourier transform of partial derivative and solution of partial differential equation with the help of Fourier transform. ये हमारा सिलेबस है, ये सब हमारे लिए इम्पोर्टेंट नहीं है. This is not required for us. But let's see, yeah, it may help sometime, but it's not required for us. Fourier transform is not required. Convolution theorem is not required. Modulation theorem is not required. It is not. This sense of scale and shifting property, these two we have to, tomorrow we'll do these two property. Sense of scale and shifting property we'll do tomorrow, and this linear. So we have property of Fourier transform 3. One is linear property, second is sense of scale property and shifting property. So tomorrow we'll start these two things. After that, if time permit, we'll find out the Fourier transform of derivative, Fourier transform of partial derivative. We can complete it. Then once we're ready, the property, Fourier transform of derivative, Fourier transform of partial derivative, then we can go for the solution of partial differential equations. Okay. So what you can do is that you please